is curved one, means something like circular arc. Okay, above this circular arc, there is a cycloid circle of 50 diameter rolls without any slip. Okay, the circumference of a circle of 175 diameter and outside it. So outside it means it is rolling above the curved path. Okay, if it is inside it, below the curved path, inside the curved path, that means we will get hypocycloid. So this is the difference. If it is outside the curved path, if the circle is rolling, then it is epicycloid. If it is inside, hypocycloid. Okay, we need to trace the locus of the point. Locus of the point, we are taking one capital P point on the circumference of the circle, which is fixed to that circle. We are tracing the path it is taking place at different intervals of time, right? So for that different intervals of time, we are conveniently taking 8 equal parts. So at 8 different times, what is the path it is taking place? Okay, so that is known to be trace the locus of the point on the circumference of the rolling circle for one complete revolution. Generally, we are considering for one revolution. So that is 2 pi r length. Okay, name the curve. So can you name the curve now? It is traveling outside the curved path. Outside it is given, right? What is the name of the curve now?
Epicycloid.
Very good.
Epicycloid.
Very good. Epicycloid. So he's asking, he's giving you question that you need to draw epicycloid. Draw tangent and normal to the curve. So when we are discussing curves, so remember always there is a at any point on the curve there is a particular normal and tangent at that particular point. Okay, and the distance where we need to draw the tangent normal, that point is also given 125 from the center of the directing circle. Here one more word you are listening, right? Directing circle. You know that rolling circle, right? Already. What is the directing circle means? The curved path. So the ground is now circular in the shape of circular arc. So it is having some particular radius, right? So that is given 175 by 2. Radius 175 by 2. So that is the directing circle. Actually, it is directing the rolling circle. That's why it is known to be directing circle. So now, if you have mini drafters and instruments with you, you can parallelly draw along with me. Okay, then it is going to be easy method. Okay, or else listen carefully. Try to ask some questions. Okay, some reasonable questions. Okay, listen carefully from the first step to the last step. Then only you can ask the questions. Okay. Uh, Now, what is the first step is here, we need to calculate a simple angle because the ground is not a straight one. Okay, we need to calculate some included angle. So simple formula, theta, you have to take theta is equal to uh, small r by capital R into 360. Small r here is rolling circle, diameter is given, okay. Capital small r here it is 25, capital R diameter is given 175 divided by 2. So 25 by 175 by 2 means how much? 8.87. Yeah, you take that ratio, multiply by 360 degrees. Okay, then you will get the included angle. Okay, you need to calculate that angle. Before that, you can write down somewhere the given data. Rolling circle radius is equal to 50 by 2. Directing circle radius 175 by 2. Okay, you can note down. Then you can take the ratio. Directly you can take the ratio, no issue. Radius by radius or diameter by diameter. You will get the same answer, right? So you can take 360 into d by d or r by r. Both are same. 360 into 50 by 170, 102.8. What are these angles? If you don't know, if you don't want to, if you don't understand, I will explain later, little later. So if you understood, no issue. Okay. Take your protractor. Okay, measure the angle 102.8, which is theta. Okay, you know how to take, right? You take any angle, any line like this, any line. You match your protractor to that line. Okay, somewhere you take a point here. Okay, uh, you match your protractor to that line, and on that line anywhere you take a some reference point O. Okay, so now this is the angle 0. Now if you see, if you go clockwise like this, okay, now this is the angle 10, 20 degrees, 30 degrees, 40, 50, 60, like that, right? Go up to, what is the angle we have taken, calculated, 102.8 degrees, right? So mark with your pencil around this protractor somewhere 102. See here, 100. It is 110 in between 100 and 110, 102.8. Okay, you can take 103 roughly. Okay, now the next important step is, now here you see, I have drawn two lines, right? The angle between these two lines must be 102. Okay, to represent the curved path, to represent the ground. Actually, it is having some circular path. Okay, now you can draw these two lines anywhere on the drawing sheet. You start the line here and you can make one or two here. Okay, so I have taken these two lines. Only the condition is, you can take these two lines anywhere on the drawing sheet, but the angle between these two lines must be 102.8 degrees. Is it clear? Can I proceed?
Yes.
Yes, sir.
Yeah. Now, those who are practicing with me, you can take time. First listen, okay? You will understand. Immediately you can draw, because we are having 10 minutes break, right? At the time, we can easily make up this particular drawing, okay? Now, we are having small r, capital R, because we are working with compass, right? Convert diameters into radius, okay? So, what is the curved path radius? What is the curved path radius? There are two radii given in the problem. One is small d, capital D, right? Yeah, I am asking, what is the path of the ground, curved path ground radius? It's a big radius, right?
125.
Yeah,
120.
170. Yeah, convert into radius. Take your compass, draw one arc from the center O. From the center O. Okay, understood? Now, here the
Please
point.
repeat once again.
Yeah, 1 minute. So from center O, you take capital R. Capital R is how much? 175 by 2, right? You locate some
7.5, sir.
87.5. You locate with the compass O as center. Take the radius 87.5 on the first line. We have already taken two lines, right? 1 or 2 degrees, right? So on the first line, left hand side, you are finding one line, right? So you take radius 87.5, O as center, mark a point P. That is the starting point on the ground. Okay, where the rolling circle also starts. Okay, so are you able to see this point, capital P?
Yes, sir.
Yeah, that's what I mean. Okay, take 87.5 radius. See, you will find how to represent the dimension. So 87.5 is the radius. Okay, you mark one point P on this particular line, and also you can draw one circular arc passing through P. O as center, OP as radius. You draw one arc. Okay, thereafter. Okay, now what is the rolling circle diameter or radius? Rolling.
25 millimeters.
Yeah, 25 millimeters. Take your compass. You draw one circle. Okay, on the same line, if you extend further, okay, if you extend OP, if you extend in the same line, extend. On that extension line, you take 25 distance. You mark the center of the circle here. Mark the center of the circle and draw the circle, rolling circle with 25 radius. Now you can observe like this. What you have to do, extend that line further and take the radius 25, draw one circle like this. Immediately after drawing the circle, along the same line, you will get one diameter, right? Perpendicular to that, you draw one more diameter line. Then you can easily divide this into 8 equal parts. Take your protractor, again take 45 degrees here, here also take 45 degrees. In that way, you can divide the circle into 8 equal parts. Okay, this is important. So are you clear up to this? I have taken OP, radius is 87.5 OP. I have extended OP line. I took 25 distant on the extension line. There I found the center of the circle. There you have taken one more circle with 25 radius. Is it clear? Can I move forward?
Sir, could you repeat from start, sir?
Start means?
From the point, sir, from the starting point. Can you want
From P.
not from P, sir, from the start, from O.
From O. Okay, you have to wait. Okay, you have to wait for some time. Now divide the circle into 8 parts. Radius 25. Okay. Now remember there is a relation between cycloidal curve and this epicycloidal curve. The numbering system, okay, line division or angle division. Here we are having angle, dividing this angle into equal parts, dividing the circle into equal parts, and numbering system. Okay, everything is same. There are so many similarities between cycloid and epicycloid. That's why while practicing or while drawing something, you need to focus carefully, observe the things happening. Okay. Now here it is, the ground is not the straight ground. You see, compare the cycloid problem. Okay. Here the ground is curved path, circular path, radius 87.5. That's why we got this angle 102.8 degrees. Otherwise, it will become, if this angle is 0, then the problem becomes cycloid only. So here, if you remember after how to number the circle. So starting point is P. Okay, starting point is P. So I said the rolling circle is rolling clockwise direction. Keep the numbering system in the anti-clockwise direction. Okay, then that's why you see the rolling circle is rolling in the clockwise fashion. Numbering is I am giving you, see the direction of arrow. It is rolling in the clockwise direction. Okay, as I said as I said, take 87.5 radius, you draw one circular arc. This is the actual ground, okay, on which this rolling wheel is rolling, okay. Understood. This circle, the circular arc, okay, which is OP radius. Initially, we have taken this OP point. Some of your friend is asking, starting from O, here, O is here, okay, and this is the included angle. We have taken OP to OP. So this included angle is 102.8 we have calculated. So OP as center, OP as radius, O as center, you draw one arc. This is the ground actually. This is the path of the ground, circular ground. Okay. So on which the roller, okay, the wheel or circle is rolling in the clockwise direction. So what I said, extend OP line further, okay, and mark at a distance 25, center of the circle, small circle. So draw a circular circle, 25 radius. So number the parts. So there are 8 parts. Okay, for conveniently we have divided the circle into 8 parts with protractor. Okay, since it is rolling clockwise direction, the number system is in the anti-clockwise direction. Now, if you remember cycloid problem, what is the immediate step we have done after dividing the circle into 8 equal parts? Do you remember?
9
Arcs from 1, 2,
dividing
3, 4,
in
5,
8
6.
parts.
Yeah,
Nine.
yeah, both are correct. Both of you are correct. There, because pi d length is there, we have divided that line into 8 equal parts. Here, there is no pi d. Here, only 102.8 angle is there. We need to divide this angle into 8 equal parts. What is the value if you divide 102.8 by 8? What is the value you will get? Calculate. If you are having a mobile phone or calculator, you just use it. If you are having a laptop, you can also calculate.
11.6.
11.6 for example. Okay, so what you have to take, again, keep the protractor. This is the starting zero line. Okay, assume this is the OP is the zero line. OP is the zero line. So mark 11.6, 11.6, 11.6, 11.6 up to this is the last end of the circular path, right? So you will get 8 equal parts. That means you are divided the circular sector, okay, into 8 equal parts. Okay, so thereafter, what is the next step? Do you remember compared to the cycloid? What is the step we have done after line division or here angle division? After circle, we
Taking
have
lines from
divided.
1 and 7, 2 and 6, 3 and 4 and 4, 3 and 5 and 4.
Very good, very good. So passing through 1 7, we have drawn one line, 2 6 one horizontal line, 3 5 one horizontal line, 4 one horizontal line. But here you will get a circular arcs because it's a curved path. The ground itself is curved path. Okay, so you don't find horizontal lines from O as center. Remember O as center. Set the radius of compass 1. O to 1. Draw one circular arc, it will pass through 7 also. Okay, so 1 and 7 is same radius. You will get 0 1 or O1 or O7, you will get the same radius with compass. So you draw arc passing through 1 and 7. This is the first arc, remember. Next, 0 to O to 2 and 6, you will get one more circular arc. O3 5, O4. In this way, you need to draw so many circular arcs. Earlier, in case of cycloid, we have drawn horizontal straight lines. But here you will get circular arcs because the roller is rolling on the curved path. Okay, curved path is in the form of circular arc only. Okay, now further take your compass, set the radius O1 or O7. You draw arc like this from 2 6. See here, yeah, here very important. Listen carefully. At the center, I am showing you some red point. Are you able to see that red point?
Yes.
Yes, sir.
Okay. While you are drawing circular arc, you will find from O to center of the circle, you will find one more special arc. Okay, you will get one more special arc. Okay, that is called center arc. That is called center arc. And from O to 6, again there is one more circular arc that may not be coincides with the center arc. Okay, there is small gap that you need to identify. Okay, O as center, circle center. If you take the radius, you will get one more special arc that is known to be center arc. Okay, and rest of the procedure is same. O to 2, you take radius, you will get one more arc passing through 2 and 6. Again, passing through 3 5, you draw passing through 4, you will get the last arc. Is it clear? Compared to the cycloid problem, what happened? Center line is passing through 2 6 only. Okay, there is no difference between center line and 2 6 line. But coming to this epicycloid, here you will get center arc, it will go separately, and arc 2 6 also goes separately. There is a small gap here that you need to understand. Why we need to draw center arc? I will tell you, because on the center line only we need to mark center C1, C2, C3, C4. Okay. In the earlier problem, in the case of cycloid, both are in line with each other. Okay, coincides with each other. That's why we did not get two different lines. Okay, is it clear how to draw these circular arcs? I will ask you a simple question. What is the center of all these arcs? Center of your compass.
Oh,
O.
Very good. O is the your uh, center of your compass. First, OP. OP is one arc. That is the curved path. OP. That is the first arc you will draw on the drawing sheet, right? What is the radius of that one? OP? OP radius?
87.5.
87.5.
Okay, that is the circular path ground. Thereafter, you will get a circle of 25 mm radius on the OP extended line. Okay, divide that into 8 equal parts. Now we come to dividing the angle. Take your protractor again and mark 11.6, 11.6. Okay, starting from OP line. OP line is the starting line. Okay, can you divide with your protractor? So you can easily divide, right? So just calculate. If it is 11.6, draw so many parts. Extend those lines up to the center arc. Okay, now this line, this angle we are dividing. Okay, or else if you are not interested to use your protractor, you can do one thing. You know how to bisect an angle, right? In that method also you can do, but he is showing that method. First you divide the total angle into two parts, then the first part again you bisect it, you will get two more parts. Like that you can do 8 equal parts. But a simple way is you take your protractor, divide 102.8 by 8, you will get 11.6. Okay.
Sir, it's actually 12.8. I said the wrong answer.
Okay, no issue. It is 12.8, so no issue. You can take with you first. OP is the first protractor 0, make it 0. Then you mark 12.8, 12.8. Then next, put small dots. Okay. Then join O to the dot and extend that line up to center arc only. That is the importance of the center arc. Okay. Extend these parts up to center arc. In the previous problem also we have drawn all the perpendiculars up to the center line only, but here up to center arc. I am comparing. Okay, don't get confused. I am comparing with the previous problem. Okay, otherwise there is no procedural differences in this particular problem. Okay, so you can use the bisector method. If you first I have to bisect 1 or 2.8, you will get two parts. Again, first part I am bisecting, you will get two more parts. Again, bisecting the first angle. So in that way, you can also divide 8 equal parts. But what I said is simply take your protractor, mark 12.8, 12.8. So automatically this 1 or 2.8 degrees will be divided into 8 equal parts. Join the dots to the and extend the dots that line up to the center arc. Name it as first center. Initially the circle at this red point, right? You call it as C0, C1, C2, C3, C4, C5, C6, C7. Of course, C0 is not, C8 is not required. Okay. So after locating centers, okay, what is the next step? Do you remember in the previous
Take even a center and draw an arc on middle center.
middle? No, no, no.
No, sorry.
Line
Line
joining 1 to
2 and 6.
7, sir.
Yeah, correct. Yeah, correct. Take
Same
center
this.
C1. Take center C1. Radius is what? Circle radius. That is 25.
2.5.
Yeah, never say 2.5. Always tell me in millimeters. Okay, 25. Okay. By default, our assumptions is All dimensions are in millimeters. So C1 as center, take the radius. Radius is always constant. Okay, don't change the compass radius. Set the radius fixed 25. Just move the centers only. Okay, now start from C1. Cut the first line, first arc. I can say first arc 1 7. Okay, from C1 as center, cut the arc 1 7 somewhere here. Okay, now C1 as center, just you take your compass, radius 25. C1, C2, all the centers are on the center arc. Okay, don't confuse with the arc 2 6. Okay, so this is the first generated point with the help of radius 25 compass. I have taken center C1, cut the, because this is the first arc, first generated point, you need to cut the first arc 1 7. Okay, then move to center C2, cut the arc 2 6. So this is the arc 2 6 arc, right? So you have to cut on that arc. Go to next C3, cut the arc 3 5. Same procedure. If you remember, if you have practiced all the previous problems, you can easily make up this thing. Okay. Now here you see, this is the curved path. Starting point of the curved path is P, right? End point of the curved path is, again you call it as P only. Okay. So starting from P, join all these red points, generated points, and end with this the last point P with smooth curve HB pencil. That is the required AP cycloidal curve. Okay. Now take your HB pencil. So this is the initial generated point, and this is the end point of the curve. So this is the smooth curve with a single stroke using HB pencil. You need to join freehand only. Don't use any mechanical tools. Okay, single stroke. Okay, don't draw 2 3 times. Okay, yeah. Now I will give you some time for questions. Any difficulty in drawing this particular sketch?
Sir,
Yeah.
what should be the center of protractor while dividing the arc, sir?
Yeah. See here, you just take your protractor. Okay. Protractor is having baseline, right? You match that baseline to this OP. OP. Okay. You match it here. Then you consider this P as 0 degrees. 0 degrees. Okay. Then you come clockwise like this. 12.8, 12.8, 12.8, like that till 102.8. You just put a dots 12.8, 12.8 around the protractor. Okay. So what you have to do is just match your protractor baseline to the OP line. OP line. Okay. And move clockwise, not in the anti-clockwise manner. Okay. Because you are matching this line, you are considering this as 0 line. Okay. 0 degrees. Now around the protractor, mark 12.8, 12.8, like that. Put dots. Okay. Join all the dots to O. Extend. You will get center like C1, C2, C3 on the center line, center arc. Is it clear?
Yes, sir.
Our main intention is this 102.8 degrees. I need to make equal parts. So that is the angle between all the angles should be same. All the parts should be same in size, okay, and shape. Everything is same. You can use any method to divide into 8 equal parts. Protractor is the best option. Okay. Any other questions? Now we are left with normal and tangent. Is asking, if you go back to the problem, What is asking? Draw the normal and tangent on the curve at a point 125 5 mm from the center of the directing circle. Now 125, okay, 125 from the center of the directing circle. O is the center of the directing circle without any doubt. Okay, take O as your compass. 125. I said 125, right? I have given in the problem. So take O as center, 125 mm radius. Cut this epicycloidal curve somewhere. Either you can cut left hand side or right hand side. O as center, 125 mm is the radius. Just cut the curve somewhere, wherever it is meeting, because we have set the radius 125 mm, right? O as center, cut somewhere on the curve with 125 mm radius. Okay, can you do that? So I got this point here somewhere. Q. Are you able to see the Q point? I'm showing you here.
Yes, sir.
So at that point, I require normal and tangent. This Q, you can also draw left hand side of the curve here also. The procedure is same. Okay. Anywhere you can take, if nothing is mentioned in the problem about the 125 mm distance, you can mark any point on the curve Q and you can draw normal and tangent at that point. Okay. So I have taken Q point at 125 mm distance. Okay. With the compass, I cut the curve. I name that intersection point as Q. Now, do you remember what is the next step? Compare this normal and tangent with cycloid problem. You would understand what is the next step. So that is very important in engineering. When you practice something, you have to go back what you have learned in the previous. Otherwise, there is no much benefit. Okay. Yeah, can you please tell me?
Sir, cut the middle.
Yeah,
Join the intersection of arc to the center arc.
correct. Both of you correct. Middle, she's telling that middle arc, okay, or center arc. But at what radius? That is important. With what radius we need to cut?
25.
Yeah, that I am expecting. Yeah, 25, because the centers are moving from C0 to C1, C1 to C2, but the radius of the circle is not changing. Okay, always 25 only. Okay, so while getting the normal and tangent, remember radius is fixed. So whatever radius of the rolling circle is there, so with the help of that radius only, we are generating the normal and tangent. Okay, so you cut with again center Q. Take your compass, center Q, cut the center arc. Okay, center arc somewhere. I will show you on the center arc. Somewhere you need to cut here. Okay. So are you able to see that arc I have drawn? Yes.
Yes, sir.
Now, so with center Q, cut the center arc somewhere here. That is the point, and still the problem is not over. Okay. Then, do you remember what is the next step compared to previous problem, cycloid? After that, what we have done?
Draw Q to center. Join.
Perpendicular from the center. In cycloid.
There perpendicular, but here
Join Q to origin.
not Q to origin. We have already drawn one arc here from Q, right? From that arc, you need to join to O. Okay.
Yes, sorry.
Yeah, from this arc we have drawn already. You can name it as some C or whatever you want, or Q or P. You can not P, because already we have taken P. Q. You can call this point as some R, capital R. Okay. and from that R you need to join to O, because this is the angle problem, right? It is having some circular path, right? It is having some center. In the cycloid problem, we have drawn one perpendicular onto the ground. Okay, here the curved path is not a straight one, so you need to join that arc to the center of the curved path. So I will show you how to draw. I actually has given the names S. Okay, capital S. Okay, so no issue. So capital S2, you need to join to the center of the path. Okay, here the question is, in the previous problem, cycloid, when you draw perpendicular, it touches the ground. Now here, that line where it touches the ground, we have joined from S to O. The question is, this line is meeting ground at which point? So this is the, yeah, so from P to P, there is a ground, right? This is the curved path radius. This is the ground actually. Remember, this is the ground. Now, after joining S to O, the ground is intersected at this point. Yeah, here. This is the ground. So here it is intersecting. You can name that point as some. So here this is M. Okay. So when you joined S point to the center of the curved path, that line is meeting the ground. Actually, this is the ground circular path at this point M. Are you clear? This is a little bit typical to understand. Okay. Is it clear to you? This is the ground path. This line S and O is meeting the ground at point M. Are you able to find out this point M?
Yes, sir.
Yeah. Now almost the problem is over. Tell me, after M, what we have to do?
Draw
Join
line.
M and Q.
M and Q, right?
Sir.
Yes, sir.
Yes. Then you will get normal or tangent.
Normal.
Normal.
Very good. So take your HB pencil. Okay. You can join MQ. And you know how to get the tangent? Anybody?
Perpendicular. Perpendicular to normal.
Normal.
From where we need to draw perpendicular? From where?
Q.
Q only.
Q.
Q. With help of protractor or mini drafter?
Mini drafter. Mini drafter.
Drafter, sir.
Yeah, you match one of the mini drafter scales to this green color line, okay, and tight the mini drafter. So just move the mini drafter at point Q, draw one perpendicular at that point Q, okay. So in this way, you can able to make up. Understood? So you can find so many videos from Manas Patnaik in the YouTube. So he can explain it, okay, with animated videos. You can watch those videos, okay. So do you have any questions now on this particular problem? You can ask any doubts. So in this way, you can able to make up
Sir,
normal,
once you explain one more time, normal and tangent.
normal and tangent, okay. So as given 125 mm distance, at that point you need to draw normal and tangent. So what I have taken is O as center, 125 mm radius. I think this screen is visible to you?
Yes.
Okay. So O as center, 125 radius, cut this particular cycloid, epicycloid. So you will get one arc here. Are you able to see this yellow shaded portion? There you will find one arc. Okay. Yes. Are you able to follow?
Yes, sir.
Thereafter, at that point Q, set your compass, center and radius 25. Cut the center arc passing through C1, C2, C3. Okay. You draw one more arc on the center arc somewhere here. Okay. Now from that center arc, on the center arc, you will find one more intersection point S. Okay, after cutting with 25 mm radius, join that point to the directing circle center O. So SO is the line you will get, and indirectly it is passing through the circular path PP line, PP arc. Okay, somewhere here you note down that point as some M. This point is M. Join that M point to Q and extend little bit away from that curve. Okay, that is the normal. Take your protractor or mini drafter better. You will get one more perpendicular on the curve. Okay, in this way you can able to draw normal and tangent on the curve at any point, at any given point, or you can choose any point if nothing is mentioned in the problem. Okay, so in this way you can able to draw normal and tangent. Okay, now can you